Everything in a neural network comes down to two operations repeated a lot. Multiply a number by a weight, then add the results. So here, let's build the first of those, that is multiply in hardware using nothing but a single component, and this is a potentiometer wired as a voltage divider. So let's look at the circuit here. Before going here, let me show you the simpler one. So this is also a voltage divider. Here we have two fixed resistance in series, as you can see R1 and R2 here. And in between these R1 and R2, I'm checking a probe like this voltmeter, and this is the V out. Here I'm basically checking. So let's come back to our main. Here in this setup, we have like 5 volt goes in at the top. That is our input signal. The potentiometer is just one resistor that a wiper splits into two. So this potentiometer, if you have ever seen the physically, you can turn the knob and you change the resistance. So basically it is in between. And here at the part where like it splits, I have the voltage right at the wiper, exactly like same here. And here, as you can see at the wiper, I'm just connected to the voltmeter that will read the voltage. In this one, as we can see, when the wiper splits these potentiometer, you get like two resistance in series. So in the current setup, it is like 1 kilo ohm, and here it is 9. The other resistors, that is R1 and R2, we can call it here. The top one is 1K and the bottom one is 9K. And let's run the simulation now. So what this V out will come here. Okay, so now let's run it, and then we see the output isn't 5 volt and it isn't 0. So it is input scaled by a fraction. You know how big the bottom resistor is compared to the whole. So here it is like 9 by the total resistance, that is 10. So that is 0.9. And when we multiply that like with 5, we get like 4.5 here. And this is the work, or basically this computation. This input voltage is like scaled by the fraction of R2 by the total resistance is the multiply setup. And if I change the voltage here, let's make it to 50. So now we will have like R1 and R2 are same. So basically we will get the ratio will be like half, and we should get the V out as the exactly half of the V in, and that is 2.5 volt. Now let's make it to 20 here, and now try to change the V in. Let's see, yeah, it's 5 volt here. The R2 is 8K, and we have this 4 volt. But in real life, what happens is that not our input. So basically, in real life, our inputs are varying. They are the varying input, and our weight, they are actually constant. So we know what exactly to multiply with to get some sort of a output. So let's change. And one thing about our feature is that it is scaled, it is normalized. So it means all the value lies between 0 and 1. And then that is multiplied with the 5 volt, so that you get like the upper limit of 5 volt in the analog setup. And then that will be like multiplied. So in real life, it will be like, for like this, which we can see output in much more precise or something. What happens if you put like 0 volt here? Of course, nothing, right? The output will be 0. The output is 0. I mean, anything multiplied to 0 is 0, right? So that is the multiplication part here.